Granularity is the extent to which a material or system is composed of distinguishable pieces or grains. It can either refer to the extent to which a larger entity is subdivided, or the extent to which groups of smaller indistinguishable entities have joined together to become larger distinguishable entities. For example, a kilometer broken into centimeters has finer granularity than a kilometer broken into meters. In contrast, molecules of photographic emulsion may clump together to form distinct noticeable granules, reflecting coarser granularity. Coarse-grained materials or systems have fewer, larger discrete components than fine-grained materials or systems. A coarse-grained description of a system regards large subcomponents while a fine-grained description regards smaller components of which the larger ones are composed. The terms granularity, coarse, and fine are relative, used when comparing systems or descriptions of systems. An example of increasingly fine granularity, a list of nations in the United Nations, a list of all states-provinces in those nations, a list of all cities in those states, etc. The terms fine and coarse are used consistently across fields, but the term granularity itself is not. For example, in investing, more granularity refers to more positions of smaller size, while photographic film that is more granular has fewer and larger chemical grains. Similarly, sugar that is more granular has fewer and larger grains. Physics, a fine-grained description of a system is a detailed, exhaustive, low-level model of it. A coarse-grained description is a model where some of this fine detail has been smoothed over or averaged out. The replacement of a fine-grained description with a lower-resolution coarse-grained model is called coarse graining. Molecular dynamics. In molecular dynamics, coarse graining consists of replacing an atomistic description of a biological molecule with a lower-resolution coarse-grained model that averages or smooths away fine details. Coarse-grained models have been developed for investigating the longer time and length scale dynamics that are critical to many biological processes, such as lipid membranes and proteins. These concepts not only apply to biological molecules but also inorganic molecules. Coarse graining may simply remove certain degrees of freedom, or it may in fact simplify the two atoms completely via a single particle representation. The ends to which systems may be coarse-grained is simply bound by the accuracy in the dynamics and structural properties one wishes to replicate. This modern area of research is in its infancy, and although it is commonly used in biological modeling, the analytic theory behind it is poorly understood. Computing. In parallel computing, granularity means the amount of computation in relation to communication, that is, the ratio of computation to the amount of communication. Fine-grained parallelism means individual tasks are relatively small in terms of code size and execution time. The data is transferred among processors frequently in amounts of one or a few memory words. Coarse-grained is the opposite, data is communicated infrequently, after larger amounts of computation. The finer the granularity, the greater the potential for parallelism and hence speed up, but the greater the overheads of synchronization and communication. In order to retain the best parallel performance, the best balance between load and communication overhead needs to be found. If the granularity is too fine, the performance can suffer from the increased communication overhead. On the other side, if the granularity is too coarse, the performance can suffer from load imbalance. Reconfigurable computing and supercomputing equals. In reconfigurable computing and in supercomputing, these terms refer to the data path width. The use of about 1-bit wide processing elements like the configurable logic blocks in an FPGA is called fine-grained computing or fine-grained reconfigurability, whereas using wide data paths, such as, for instance 32 bits wide resources, like microprocessor CPUs or data stream-driven data path units like in a reconfigurable data path array is called coarse-grained computing or coarse-grained reconfigurability. Data granularity the granularity of data refers to the size in which data fields are subdivided. For example, a postal address can be recorded, with coarse granularity, as a single field, address equals 202nd Avenue South number 358, St. Petersburg, Florida, 33701-4313 USA, or with fine granularity, as multiple fields. Street address equals 200 2nd Avenue South number 358, city equals St. Petersburg, postal code equals Florida, 33701-4313, country equals USA, or even finer granularity, street equals 2nd Avenue South, address number equals 200, suite apartment number equals number 358, city equals St. Petersburg, state equals FL, postal code equals 33701, postal code add-on equals 4313, country equals USA. Finer granularity has overheads for data input and storage. This manifests itself in a higher number of objects and methods in the object-oriented programming paradigm or more subroutine calls for procedural programming and parallel computing environments. It does however offer benefits in flexibility of data processing and treating each data field in isolation if required. A performance problem caused by excessive granularity may not reveal itself until scalability becomes an issue. Photographic film. In photography, granularity is a measure of film grain. It is measured using a particular standard procedure, but in general a larger number means the grains of silver are larger and there are fewer grains in a given area. Notes. References to Pablo, J. Coarse-grained simulations of macromolecules, from DNA to nanocomposites. Anu. Reverend Phys. Chem 62, 555 €74 doi, 10.1146/January Film 032210-103458. PMID 21219152. Spacey, S. Luck, W. Kelly, Ph.J. Kuhn, D. Improving Communication Latency with a Write-Only Architecture. Journal of Parallel and Distributed Computing 72, 1617 €1627. doi, 10.1016/JJPDC. 2012.08.007. See also, granular computing, multiple granularity locking, particle size.